So A to B directly the power longer than to A to B, and as well as it is a C to B also we are taking here. So that is a major function. We are taking that. What is a metric space? What's a metric space means A, B, C, D. We are writing in A, B, C, D. We are writing A, B, C here. So that is a D function also in the metric space. What we have to write here. So in the bar of X and Y, namely modulus of X minus Y. So a non-empty set X is said to be a metric space. Two elements X, Y, comma belongs to X. So dx comma y greater than 0, dxy is equal to 0. So therefore dxy is equal to dxy. But with symmetric means what? Dxy is equal to yx. We can write here x comma y is equal to x, y comma x. So dx comma y less than or dx comma z plus dz comma y. It is triangle inequality. We note that D is a real function is defined in the orders pairs of element X and Y. D metric on X, the metric space, non-empty set X, D is appropriate. D is appropriate to write metric space as pair X comma D. So we are taking X comma D here for any two elements X comma Y. It is a unique number we are taking here. Dx comma, which is distance between X and Y. Next, the elements of the metric space are also called points we are taking here. So are you listening?
Yes, listening.
So examples of metric space, wait for 2 minutes, I will come back. Okay, don't worry.
అది ఇల్లే వస్తుంది
అటు పెట్టుకుందాం ఆ వాల్ పెట్టేస్తుంది ఆ వాల్ పెట్టేస్తుంది दियाले हेलो प्रवलिका audible 5 minutes दिया 5 minutes అండి దీంతో మీటింగ్ ఉంది 5 minutes wait
okay
don't go anywhere don't go anywhere within 5 to 5 minutes I will take back again
okay
Dayak అన్ని ఒక్క దగ్గర పెడతాం
5 వస్తాం పెట్టాము 5 10 వచ్చినాయి లేదు పూర్తిగా కొట్టి అక్కడ
అటు పెట్టేసి
ఇది తీస్తాం పెట్టేద్దాం అది 15
రాజు మేడం మేడం
చిన్నది పేపర్ లో మ్యాథమెటిక్స్ అండ్ స్టాట్స్ అని రాసి పెట్టుకోవాలి.
పెడతా
అట్లాగే ఇక్కడ ఫిజిక్స్ అని రాస్తాము.
అక్కడ
చిన్న స్లిప్.
రాజు రాజు ఏ ఆగుసా మీకు ఒకటి నాకు క్లాస్ ఒకటి క్లాస్ ఒకటి ప్లీజ్ నేను మేడం చెప్తా. ఇగో అన్న నేను హెల్ప్ తీసుకో. టేప్ ఉంది ఇక్కడ. పెట్టేసి Kavalika.
Sir.
Wait for 5 to 7 minutes. Don't go away, please. Don't go away. Please. Hello. Hello, Pravalika. I am audible. Pravalika.
Yeah, sir, you are audible.
Yes. What is the yes. What is the metric space? Tell me. What is the metric space? What is the metric space? Oh, see the textbook. I will explain that tomorrow also. This one. Don't worry about it. I will explain tomorrow also.
Can you please unity?
और ऊपर
ఏ క్లాస్ నడుస్తుంది
Sir,
Class
can you
నడుస్తుంది.
tell me which unit it is?
What is the metric spaces?
Sir, which unit it is?
What is the
Can
metric
you please
spaces?
tell me? Which unit it is?
Hello?
Sir,
First unit
actually
tell
this
me.
is the first unit. Finite the
Hello?
differences.
What is the theorem? What is the theorem? See the page number 3 or 4 you have to see.
Sir, it is the
What?
subject numerical.
No, उधर
Expansion.
अदोट बेटा tell me what is the దయాకర్ ఇది ఇక్కడ పెట్టు ఇట్లా రాదు దయాకర్ ఇది రాదు. What is the metric space? You have to see the first question. What is the metric spaces?
Next question.
You have to see the textbook. Today just now told me to take the class, so don't worry about it. Tomorrow I will repeat again. Okay?
Yes, sir. The first unit is
Hello?
finite differences, right?
Yes.
Differences, right? First unit.
Yes.
Yes. In
Yes.
that
Tell me.
metric space. Any idea regarding metric space?
Petition. ఐదు రెండు ఇంకా మూడు ఉంటాయి.
Actually, I don't have any idea, sir.
Yes, tell me, I'm listening.
I don't have any idea regarding metric space.
Okay. Wait for science. Wait for 10 minutes. I will go to the system and I will tell you. Okay? Okay?
Okay.
Hello?
Okay.
Travel. Okay. Stay on the line, please. Pravalika. Pravalika.
Sir.
Yes, yes, wait. No, one another person wait. Just stay on the line. Just stay for 2-3 minutes. Waste. Just 2-3 minutes. Watch. లాస్ట్ గా అది ఏం చేసినారు బర్త్డే Our services needed. అన్న మిద్దెలిగో డిపార్ట్మెంట్ ఆఫ్ మ్యాథమెటిక్స్ అని మధ్యలో పెడుతున్నా ఇటు స్టాటిస్టిక్స్ అని పెట్టేసుకుంటా బాగా ఉంటాయి దాన్ని ఏమంటారు పవర్ పాయింట్ ప్రెజెంటేషన్స్
ప్రాపర్టీ ఎక్స్పెరిమెంట్స్
ఉంటాయి కానీ మన సిస్టమ్స్ ఉండాలి మనం
లేదు బల్బ్ తీసుకొని
అవి ఎడ సరిపోతుంది ఉంటాయి
కార్డ్ ప్లే
ఉంటాయి ప్రాబిలిటీ
ఒక పికప్ చేయమంటారు
టాస్ వేసి అవన్నీ ఉంటాయి ప్రాబిలిటీ స్టాటిస్టిక్స్ ఉంటాయి ఎవరు చేయాలి Pravalika,
Sir.
Just see the your textbook first.
Yeah.
Just see the textbook first.
Yeah. Finite differences, the first unit.
We have to see here, so we have to see the experiment. By book. An open sphere in a metric space is an open set. If x belongs to x or greater than 0, consider open sphere SRX. So y belongs to SRX dx comma y less than r. So consider SR1y. R1 is equal to r minus dxy. So we shall show that SR1y less than SRX if z belongs to SR1y, dyz less than r1. So what is the condition is SRX, and SRX means it is an open sphere what you are taking. What is the open sphere taking here? So d of x comma y is less than r. So we can do SR1y, r1 is equal to r minus dx minus y. So SR1y subset of SRX. So z belongs to SR1y, dyz, d of yz less than r1. So d of xz less than or d of xy plus d of xz is equal to d of xy plus r1. So therefore, xy and yx we are taking the comparison here. So d of xy plus r minus d of xy is equal to r. Z belongs to SRX, SR1y subset of SRX. SRX is on open set we are taking here. So this is the main theorem here. And X is a metric space. If G is open subset of X, then G is the union of sum of open sphere X. So see here, G is the empty set we are taking here. So the union of the empty set class open spheres, the result is true. Then G is non-open empty set. So X belongs to G. There exists real number Rx greater than 0 such that SRX less than G. G is equal to U of X union G SRX X. Rx is used to emphasize that it depends upon the Z here. In metric space X, the union of any collection open sets is an open set. Y. Intersection of the finite number open sets is an open set. So therefore, let be any set of indicates G alpha. Alpha belongs to every open sets of X. So if F is any empty, the above class G alpha is an empty set. G is equal to U alpha is also empty, and hence G is open. If F is non-empty, I is non-empty, X belongs to G implies here. So X belongs to G alpha. What is we are taking here in the X condition? The G is the metric space. G alpha is I alpha belongs to. Since G alpha is open, so there is a real number R greater than 0 such that Rx is such less than G alpha less than G. How we can find an open sphere contained in G? Consequently, G is an open set. Why is open set we are taking here? Y is equal to 1 to N, G is equal to intersection of I is equal to 1 to Gi. So X belongs to G. Subset of interval. So minimum of R1 R2 Rn. So that is called open set. The following example, we can take one example. Gi is equal to minus 1 by I is equal to 1, 2, 3. So therefore G is equal to 0, X
Please
not
use the board, sir. Please use the board as system.
is equal to X not equal to 0, R not equal to 0. So then we can find the radius of this one. Then open sets also, open sets for relative subspaces. Now understanding, Pravalika?
Yes, sir. Can you please use the board as system?
Tomorrow. Because today I'm taking on my mobile, not system working, and tomorrow I will blackboard I will tell you. Don't worry.
If it is visible, then I will understand. Then if it is not visible, I can't understand properly.
Yes, I understood. Tomorrow. Pravalika.
Yes, sir.
Hello. This unit I will teach tomorrow also. No, don't worry.
Sir, I have one doubt, sir. You are explaining the first unit, that is finite
Hello.
differences. In that,
I did not understood.
there is no word metric space. There is all finite differences, backward difference, forward difference.
No, backward and back.
There is no word like metric space in the first unit. Hello?
Backward, forward differences.
Sir,
Pravalika.
your voice is not audible, sir.
Now I am
Yes.
audible.
Yeah, sir. Yeah. Now.
So metric space and what is that? I will teach on the blackboard tomorrow. Okay.
Yeah, sir. I have one doubt, sir. That is interpolation. Here I have in the textbook that interpolation and
Where is
extrapolation.
interpolation?
Sir, it is the
Where?
subject numerical methods, right? Sir, you are teaching the subject numerical methods,
The
right?
second year student. You are the second year student, now.
Yeah, sir. I have. That's why I am beginning onwards. I am a second year student. There is
Okay.
no word metric space in the
Okay,
text.
that's no. I forgot. I
Actually,
forgotten. Tomorrow and I will use the blackboard.
Okay. This is the time 3 to 4 for
I
PG
understood.
second year. Yes, sir.
Yes. I agree with you.
Yeah,
Agree with
that's
you. Tomorrow on the
beginning
blackboard we will
onwards. I
discuss.
am confused. Where is the word metric space? Actually, the unit is finite differences. Sir is telling metric space. Then I confused it. Yeah, sir. That is in first year metric space.
Okay.
Yeah, sir.
Okay. Tomorrow I will speak. Tomorrow I will let us we can discuss. Numerical methods. Just wait. I will have any problem is there. We can see here.
Yeah. Okay.
Just a minute. I am taking here. I forgot, you are the first year student, I think.
No, sir. This is the time actually 3 to 4 for 9B numerical
Yes, yes, I
method.
forgotten.
Okay.
Just a minute. Just to stay on the line. Numerical methods you want here, or just a minute. So in this, you are told that in that. You told that here in the interpolation one I am taking here. What's the interpolation we'll take here? Just a minute. Share screen. Document. So tomorrow I will share the screen. Don't worry about it. Okay. Are you understanding, Pravalika? Tomorrow we will take on the board. Okay.
Okay, fine. Okay.
No problem with you. Tomorrow we will take the board.
Yeah.
Don't worry about it. I am taking the. Just I'm telling the on phone today. Tomorrow I will speak on. Tomorrow I will speak on the board. Don't worry. Okay. We will speak tomorrow.
Yeah, sir. Sure. Sure.
Thank you. Thank you.
Shall I leave the meeting? Shall I leave the meeting, sir? Shall I leave the meeting?
Just a minute. I'm sharing the screen. Just wait. If supporting the screen today, I will tell you some more. Okay.
Okay.
Just I am downloading that. Just a minute. I'm try again. Just a minute. I'm sharing the screen from comment. Yes, the screen is visible now.
Yeah. Yeah.
The screen is visible, Pravalika.
Yeah.
Finite differences.
This is the subject.
Finite.
Yeah.
Yes. So this tomorrow the service error, the rounding error, the truncation error that refers the error. So the approximation numerically solving a mathematical problem, it is the error generally associated with the subject of numerical analysis. So it involves approximation of the finite process of the finite series, replacing the non-computable problems with the computable ones. So the summation of is equal to 1 to 1 by n. So that is the values. What is the error we are taking here? So this is the modeling error and measures of error we are taking. The Taylor's expansion also in the Taylor's expansion is there. So the Taylor's expansion also I'm telling here. The one of the Taylor expansion is the common error to the absolute number t by the under t bar. So the absolute error is usually defined t minus t bar. They correspond to the idea that t, the corresponding idea t, and that we are taking the t, the number of decimal places we are, the number of decimal places we are taking here. So what is the decimal places we are taking that in the condition here? And the Taylor expansion, one of the most important tools, the numerical analysis of the Taylor theorem and that the associated Taylor series. The theorem gives a relatively simple method that approximating functions by x polynomials and the other method by computing f of x. So let f of x that a continuous derivative a comma b greater than 0, x comma 0 a belongs to b. So therefore, we can take it f of x pn minus 1x or in x. So pn minus 1x, what is the function here? F of x naught, formula f of x naught plus x minus x naught 1 by 1 factorial, and f of x naught x 2 factorial by f double dash x naught, x minus x naught by 3 factorial f triple dash x naught. So the final, it's going out f plus x minus x naught n minus 1 by n minus 1 factorial f of n minus 1 x naught 0 we are taking here. Or in x6, we are or in x we are taking here x minus or in x. Or in x we are taking 1 by n minus 1 factorial integration of, just a minute. Basics I am now telling. Tomorrow we will discuss on the board also. Okay. So here sigma 6.1.6 here, the measures of error. So I told that the Taylor expansion 1 by n minus 1 is a summation of, so it's not going here. Again I'm telling you the first pages is going to the errors. Some of the values I am telling here. Integration of see here some integration of x naught of x minus 2 whole power n minus f of n power dt x minus x naught whole power n by n minus factorial. That's the sum of theta integers x naught minus x we are taking here. So what is the finite difference? The forward difference operator. Suppose you have to given the tabular form x equal I is equal 0 1 to n sum of function. Sum of function we are taking here y is equal to f of x, where the independent variable takes spaced values we are taking x plus I is equal 0 1 to n is called interval difference. So forward difference formula, the forward difference that is a delta is defined by delta I1 delta I plus 1 minus I, delta Iy is called the forward difference of yi. So what is the forward differences means? Your the delta we are taking delta r1 plus yi, delta y plus y I plus 1 minus y delta r. So we are taking these conditions in that delta r y plus 1 y minus 1 delta r y plus 1 delta r yi or greater than 0 delta power 0 yi is equal to yi. Delta or y is called orth forward difference y. Is the differences are written in the formal table differences table here. So we can take that the condition here. What is that? R plus 1 or delta or r plus 1 y, delta r yi plus 1 minus y, delta r I plus 1 minus delta r yi or greater than 0 yi. So that the forward difference formula we are taking the forward difference table. We are taking x0, x1, x2, x3, x4 in x condition. Then y0, y1, y2, y3, y4 we are taking. So delta y0 is equal to we are taking the second value for minus first value. Second value minus first value we are taking here y1 minus y0. Delta y1 is equal to y2 minus y1. Delta y2 is equal to y3 minus y2. Delta y3 is equal to y4 minus y3. Del square y0 is equal to del y1 minus del y0. Del cube y0 is equal to del square minus, and the between the values we are taking del square minus del square y1 minus del square y0. So del 4 y0 is equal to del cube minus del cube y1 minus del cube y0. Del cube y1 minus is equal to del cube y square minus del square y1. Del square y2 is equal to del y cube minus del y. So these values in the problem we are doing here from the difference table 0 0 1 1 2 8 3 2 7 and 4 6 4. Del square y0, del square y, del y2 0 1 2 3 4 given the values, and y values also taken 0 1 2 8 27 64 in the brackets. So the first column is x and second column is y. Am I correct, Pravalika? Hello, Pravalika, you are listening? Okay, so see here 0 1 minus 0 is 1, 8 minus 1 is 7, 27 minus 8, 19, 67, 64 minus 27 is 37, 7 minus 1 is 6, 19 minus 7, 12, 37 minus 18 is equal to 18. So I am taking the minus 12 minus 6, 6, 18 minus 2, 6, so 6 minus 6 is equal to 0. So what is the value? So we are taking del y, del square y, del cube and del 4y. So we are writing the values here. Del square y naught is equal to, del square y naught is equal to, what is the last for del 4 y naught is equal to 0, and also del 4 y naught is equal to 0, and del square y1 is equal to 12, and also del y2 is equal to 19. So 19, 12, 6 also we are taking here. Del y4 not is equal to 0, del square y is equal to 6. So observe that the given data function is y is equal to x cube degree of polynomials. So del cube is the constants equal the 4 order difference sequence is 0. So obtain the first 4 differences function y is equal to x square, h is equal to 1. Also show that the second difference is a constant we have to do. But the backward difference or operator nabla. The backward difference operator nabla means nabla y1 is equal to yi minus yi minus 1, or nabla r plus 1 y is equal to nabla r y minus nabla r yi minus 1 r greater than 0 we are writing here. So therefore we have the values we are writing. What is the values we are writing here? R greater than 0, nabla y is equal to yi. So x is equal to x0, x1, x2, x3, y is equal to y0, y1, y2, y3. So we are also taking here nabla y1 is equal to y1 minus y0. Y1 is second value and minus del 2, y2 minus y1. Nabla y3 minus y2, same del square y2. The nabla y2 minus nabla y1, nabla y3 is equal to nabla y3, nabla y2, nabla y3 is equal to nabla square y3, nabla square y2 we are taking here. So observing here that values here we are taking here. So therefore del y0 is equal to del y1, del nabla y square is equal to y2 is equal to del square y0. So etc. we are taking the formulas here. So what is the shift operator? The shift operator dy is equal to yi plus 1, yi plus r del 0 yi. So this is the operator. E will shift the next value for the x is the rational number and the differential averaging operator mu. The averaging operator mu is equal to 1 by 2 e 1 by 2 plus e power minus 1 by 2. So what is the averaging operator? We are taking that the condition mu is equal to e plus 1 by 2 and e power minus 1 by 2. That is called u y is equal to 0 plus 1 e power 1 by 2. We can write y 1 by 2 plus y minus 1 by 2. What is the central difference? What is the central difference we are taking here? Consider a function. Consider a function a tabulated value. Space argument x0 plus x0 plus 2h. We are interested in the behavior of the wave. Y in the x0 x plus we make the transformation x minus x0 plus rh by h, so that the value what we are taking here y naught x0 plus rh will now become a y naught and the interval differing 1. Then the difference table is given by x0 plus r minus 2h. R minus 2h is bar. Then r minus 1h is the second one. Then x0 plus rh. In the x0 plus 1 r plus 1 plus the x0 plus rh is the center one. Then x0 plus r1 plus h, x0 plus r plus 2h. So why are taking the x0 plus r plus h? We are taking is now 0. So the upper values is minus 1 and minus 2. Beginning was 0, 1, 2. We are writing minus 2, minus 1, 0, and plus values y and 2. Delta y is equal to, that is first one, delta minus y2, delta minus 1, del y0, del y1. Take the minus here. And del square minus y2, del square minus 1, del square y0. So we are taking the value, we are taking the values here. We are taking the values here. Del square y0 minus del square y1, del square y minus 2, we are taking the values here. So therefore we are functioning that one in the, how to find that values in that one. So therefore now I am finding another problem here. So another problem you have to do is that using the tabulator value, y naught is equal to minus 5, y1 is equal to minus 10, y2 is equal to minus 9, y3 is equal to 4, and y4 is equal to 35, obtain y. So 0, 0, 1, 2, 3, 4, 5. The values I am writing minus 5, minus 10, minus 9, 4, 35, 90. And then we are writing the values here same. minus 5 minus 10 minus 10 4 35 90. So del y minus 10 plus 5 అంటే minus of minus minus 5 minus 9 plus 10 plus 1 4 plus 9 13 35 minus 4 31 90 minus 35 55 again 1 plus 5 6 31 13 minus 1 12 31 minus 13 18 55 minus 31 24. So what is the values we are taking? 12 minus 6 6 18 12 6 24 minus 18 6, all the values is 6. So we are writing here in the denominator del square y2, del square y2 is equal to 6, del square y3 minus del square y2 means del square y3. What is del square y3? 8. Del square y3 means 18. 18 minus 2 is 16. So therefore del square y3, del square y2, what is del square y2? 18 plus 6 is equal to 24. So similarly del y cube also we are doing here. This is the one of the procedure with this one. Then another example we have to take it. Find the missing value of y3 using the data. Y0 is equal to 580, y1 556, y2 550, y4 385, and given the data is represented a cubic polynomial. As it is a given that the cubic polynomial given the represented data in third order, difference is y constant, delta power 4 is delta power 4y is equal to 0. Delta power 4 y not equal to 0. So we can take here e minus 1. E minus 1 whole power y naught is equal to 0. So e power minus 1 whole power 4. E, that is we are expanding up to power 4. Up to power 4 means e power 4 minus 4e cube plus 6e square minus 4e minus 1. That is expanding. That is y naught equal to 0. Otherwise, we can write that e power 4 y naught multiplying this to y naught 4e cube y naught plus 6e square y naught minus 4e y naught plus y naught is equal to 0. Or also we can write here, that is we can write here y for e power 4 means y power 4. 4e cube means 4 minus 4y cube. 6e square minus plus 6y square minus 4y1 plus y naught is equal to 0. What we are writing? These values substituting y4, y2, y1. So we get the values of y1. So there are some problems of the exercises here you have to do here, and the interpolation and the extrapolation. In the interpolation and the extrapolation, Newton forward interpolation formula. Let y is equal to f of x, let y function whose explicitly may be known, which takes the y0, y1, y2 in corresponding the equalization district x0, x1, x2, xn. That is a required p of x polynomial degree, and the y in px is coincide the tabulated points. Assume the polynomial to be the form. So we can take here p of x is equal to a0 plus a1, a1 x minus x naught, a2 x minus eta, x naught, a3 x minus x naught, x minus x1 plus a3 x minus x naught, x minus x1, x minus x2, and so on. We are taking an x minus x naught, x minus x1, and so on, x minus xn. Now the n plus 1 coefficients we are taking a0, a1, an are determined such that p of x naught is y, x naught is equal to y naught, p of x1 is equal to y1, p of xn is equal to yn1, yn. So n plus 1 conditions are satisfied. How it is satisfied? Let x naught r plus h is equal to r is equal to 0, 1, r is equal to 0, 1, 2, 3, n we are r is equal to 0, 1, 2, 3, n we are taking here. So the r is equal to 0, 1, 2, 3, we are taking that values, we'll take the consideration here. So we are taking that here r plus x naught plus rh, r is equal to 0, 1 to n minus 1. Substituting x naught, x is equal to x naught. So we can take p x naught is equal to y naught is equal to a naught. So there we are writing y naught is equal to a naught. So put x is equal to xi. You get pxi is equal to y1 is equal to a0 plus a1 x minus x naught. Y naught is equal to a1 plus h. So what is a y1? A1 we have write y1 minus y naught by h, or we can write del y naught by h. Y del x is equal to x is equal to x1 and x is equal to x2, x is equal to x3. We are substituting here. X is equal to x3. X2 is equal to substituting in the above equation. P of x2 is equal to y2 a0 plus a1 x2 minus x naught, a2 x2 minus x naught. Here reversely taking x2 minus x naught plus x2 minus x naught. So therefore y is equal to y1 plus y naught by h into 2 into h, that is 2 into h we can write here. So therefore a2 is equal to, also we can write here y2 minus 2y1 y naught by 2h square, 1 by 2 factorial h square del square y naught. Similarly, a cube is equal to 1 by 3 factorial h cube del cube y naught, n is equal to 1 by n factorial h and del power n y naught. Substituting the values a1, a0, a1 and so on, an. So these equations we are substituting in the above equation. P of x is equal to y naught plus x minus x naught del y naught by h plus x minus x naught, x minus 1 So we are x minus x naught, x minus x1, we can take the del square y naught. Del square y naught means 2 factorial by h square. So what is the 2 factorial? Del y naught by hn, we are taking x minus x naught. Then x minus x naught, x minus x1, x minus x2, del square y naught, 3 factorial by h cube, and so on. X minus x naught, x minus x1, and so on. X minus xn minus 1 del power n y naught by n factorial h power n. This is Newton for interpolation formula we are taking here. This is a formula may be written as in the changing of the variable. X is equal to x naught plus x naught plus hu. U is equal to x naught, x minus x naught h. So there 0 less than u less than is general. Then p of x is equal to p of x is equal to we have p x naught plus hu, u delta y, u plus u1 minus 2 factorial by del square y naught, u into u minus 1, u minus 2 by 3 factorial del cube y naught, and so on, u minus 1, and so on, u minus n plus 1 by n factorial power n y naught. This is called Newton formula. This is Newton forward interpolation formula. Once usually this formula is useful estimating the value of the x at the beginning of the tabular form with accuracy. So this is what we are substituting the values. X is equal to 1, x0 is equal to 1, x0 is equal to 1, x0 is equal to x0 is equal to 3. In the beginning of the formula we are substituting the values. Then p of x values we are coming. But x naught is equal to x, but x is equal to x naught plus hu means u is what's the fundamental, what the given that the values we are finding here, u is equal to x minus x naught h. That's a formula we are writing, that is 0 less than u less than 1. These values are substituting, that we can get is the numerical Newton's forward interpolation formula. So Newton formula for backward interpolation formula for estimating the value of y corresponding the value of x need in the tabular form. We are taking also here we are taking p of x equal to a0 plus a1 x minus xn, a2 x minus xn, x minus xn minus 1, and so on, also x minus n xn, x minus xn plus, and so on, x minus xa. Also we are taking these values here. This Newton formula, we backward formula we discuss tomorrow's class, and these Newton formula backward interpolation we will clarify on the board. Any doubts, ask me, I will clarify. Please. Please, any doubts? Any doubts, please? Any more doubts? Any more doubts, please? Okay. So Newton forward and Newton formula backward interpolation formula also we will discuss tomorrow. Thank you.